Alright, well, this was a pretty rough little equation, but let's try to do it. We just got parametric equations here. We got x and y's. When combined together, they form this particular curve right here. We're going to be rotating it about the y-axis. And when we're going to be doing that, we have these equations. 2 pi from a to b. And if we're rotating around the x-axis, we're going to use the opposite letter. That's going to be an x. And then we have a ds. Very simple. All right. Now, keeping in mind that ds, regardless of whether it's x or y here, ds is always the same. It's going to be dx over dt squared plus dy over dt squared. Okay? And if we are going to start plugging this in, we're going to have s equals 2 pi, actually, first, let's take the derivative of, let's do it over here. ds equals square root of dx is just 1, isn't it? Do we even need to add the squared? 1 squared is 1. And then over here we have the dy over dt. Let's figure out what dy is. Well, if we need to rewrite y, it's actually going to be 1/2 d squared plus square root of 30 t. That's just rewriting that. And then to take the derivative of that, it would actually be 2 over 2 t plus square root of 30. This just goes away. We're left with t plus square root of 30. That's what goes over here. Okay, then we're going to square that. And that's what ds is. We can go ahead and plug this back into this little equation. S equals 2 pi. And then we're going from negative square root of 30 to 30 over here. And then x is actually just this. So t plus square root of 30. And then we got the big square root over here, 1 plus t plus square root of 30 squared. There we go. Now, when you see this kind of setup where you got the x, 1 plus x squared, notice that would be x squared. If you see that, you know you can integrate easily, because if you take the derivative of this, and it's just kind of on the outside right here, the derivative of the inside is x, and then it's on the outside, that means it's going to cancel out. So you can take a nice easy derivative here. We're going to do a u sub. U equals 1 plus t plus square root of 30 squared. And then we're going to take the derivative of all of this. It's going to be du equals 2 t plus square root of 30. The derivative on the inside is 1, so that's it. It's just dt. You could divide that on both sides over here. That'll get rid of this, leaving you with dt equals that. Now, this is what we're going to be plugging in into our equation over here. So, back on this side, s equals 2 pi. And if we plug u equals, t equals negative square root of 30 on this side, and t equals square root of 30 up there, then what happens is, in this equation, if t is negative 30, this is just 0, and u is 1. That's just 1. And then over here, if t is square root of 30, then that's going to be 121, right? Just kind of doing the math in my head. Square root of 30, it's going to be, yeah, go ahead and do that. It's 121. Anyway, so the idea is that now we're going to be plugging, let's keep this here, 2 plus square root of 30 over here. But then it's 1 plus, actually it's not even 1 plus, it's just u on the inside. It's just square root of u. Square root of u. And then there's this dt, which will turn into du over 2t plus square root of 30. The 2 cancels out over here, the t's cancel out over here, and we're just left with s equals pi 1 to 121 square root of u and du, which is going to be an easy integral. You could rewrite this as u to the 1/2, which then becomes 3 over 2, 2 over 3. And so that's what the integral is. Here's 2 u over 3 to the 3 over 2, 1 to 121. Easy peasy, lemon squeezy. Should be no problem to plug this into the calculator. 121 to the 3 over 2 times 2 divided by 3. We get 266 over 3 minus 2 over 3 pi. I guess that's 2660 divided by 3. Alright, pretty nice answer. That's that right there. Hopefully that wasn't too difficult.